So let's do it. We're going to start with 8.4. Adding, subtracting, and multiplying radical expressions. So adding and subtracting radical expressions is very similar to adding terms in a polynomial. We combine like terms where we can. So what do like radicals look like? What like radicals look like? First, they have the same radicand. They have the same radicand, meaning it's the quantity under the radical or the root sign. And let me just show you. Number 5, for example. This is the radicand. All right? Now, and they have the same index. Index. What's the index? The index is showing us what kind of root is being taken. So let's say this is the index. Okay. Now, let's do a few examples, all right? Let's start with this one. We're going to add and subtract. All right, so the first one. Here's the first one. We have 3 square root of 2 plus 7 square root of 2. So what is that equal to? We have the same radicand. So what do we need to do? Just add the coefficients, which is going to be 10 square root of 2. Now, the next one. The next one we have 8. This is the cubic root of x minus the cubic root of x. So what do I do? Again, have the same radicand. So 8 I subtract the coefficient. Here's a 1. 8 minus 1 will be 7 cubic root of x. Let's do this one. We have a square root of 6 minus 0.25 square root of 6. What do I do? We have a 1 here, remember. So 1 minus 0.25 is 0.7. All right. And the last one, square root of y minus square root of y. That's equal to what? To 0, right? Not bad. Now, I have, let's do this one. Look at this one. It's a little bit different. We have 3 times the square root of 2 plus the square root of 8. All right? So they are not like radicals. They're not. But what we can do is so we need to try to simplify them, okay? Either one. In this case, we're going to try to simplify the 8 That's the one that we can simplify. So square root of 8, we know is equal to the square root of 4 times the square root of 2. And we know that the square root of 4 is 2. So 8, square root of 8 is equal to 2 times the square root of 2. So we could replace the square root of 8 with this term. And that's exactly what we're going to be doing. So we have 3 square root of 2 plus 2 square root of 2. And I have the same radicands. I'm going to add the coefficients. And what do I get? 5 square root of 2. So we just needed to simplify it, okay? Now, we're going to continue adding and subtracting. So number 5, this should be 6. We're going to be adding or square root of 18 plus square root of 8, right? Now, so what do we do here? What are the factors? 18. How do we divide 18? That in two numbers, two factors. One of them is going to be the square, which is 9, and the other one is going to be the one that is left. The same here. What's the square? 4. And what's the one that is left? 2. Right? So we know that the square root, we know that the square root of 18, we can write it as what? The square root of 9 times the square root of 2. So this is going to be the same, square root of 4 times the square root of 2. 9 times 2 is 18. 4 times 2 is 8. So now square root of 3 is 3 times the square root of 2 times the square root of 2. Now let's multiply here. What do we get? 12 square root of 2 plus 2 square root of 2. Again, we have the same radicands. Now we could add the coefficients. What do we have? 14 square root of 2. So our goal was to get this one. That's what was our goal. Once we have the square root of 2, we were able to add them. And also, how did I break this one? Find two factors. One that is the square and the other one is whatever is left. Okay, let's do another one. Number 7, 375 minus 4 square root of 20. And let's see, 25. 25 would be 25 times what? Times 3. 28. 4 times what? 7. And this one stays the same. This one is not going to change. So let's see. We have 3 times the square root of 25 times the square root of 3. We have the 4, and we have the square root of 4 times the square root of 7 plus 7. Now, square root of 25 is 5. Square root of 4 is 2 plus square root of 7. So now what do I get here? 15 square root of 3, 8 square root of 7 plus square root of 7. Right? So this one, I can't do anything, but I still can work with this 2. Remember, here's a 1. So this one is going to stay the same, but I can combine these 2. And that's going to be 7 square root of 7. Okay? And this is my answer. Let me do another one. So we have, I think this one is 8. This is the square root of 75x minus 3 square root of 27x plus 12x. All right, there we go. Now we need to, let me find the numbers. So it's going to be 25 times what? Times 3. This is the square. 27 would be 9 times 3. And 12 would be 4 times 3. Seems like we're going to have the square root of 3. So we have the square root of 25 times the square root of 3x minus 3 times the square root of 9 square root of 3x plus square root of 4 times the square root of 3x. I don't know if you guys see this. All the same. Now, this is 5 square root of 3x. This will be 3 times 3, 9 square root of 3x plus 2 times square root of 3x. So what do I do first? Order of operations from left to right. We're going to do this one first. What do we get? Negative 4 square root of 3x plus 2 square root of 3x. Now we combine these two and we get negative 2 square root of 3x. And that's the answer that I got. Okay. Again, let's go back here. Find two numbers. One of them is going to be the perfect square, the square that you can say 5 times 5, 3 times 3, and 2 times 2. Let's do this one. I have 9. This is 4. 5x to the 9 plus right? Yeah. Now. This is to the 9th, the 4th, 7th. Okay. So let's start. This is going to be what? X to the 8th power and X, right? And right here, we're going to get the number. So it's going to be 9 times 5. And this one, 4 times 5. And this is going to be X to the what? To the 6th times X. So let's do it. We have 4 times square root of 8 times 5x. That's what we have left. We have x to the 4 square root of 9 times the square root of 5x minus, we have the x, we have the square root of 4, and the square root of 5, square root of x squared, and the x. That's what we have there, okay? Now, what's the square root of x to the 8th power? 8 divided by 2 is x to the 4th power. All right? Now, what's the square root of 9? 3. Now here, what do we have? The square root of 4 is 2. So 2x. And how many do we have here? Divided by 2 is 3. Plus 1, 4. And these two, we're going to combine it, 5x. So we have 5x and 5x. And we have x to the 4th power, x to the 4th power, and x to the 4th power. So we can combine all those terms. Let's add those two. That's going to be 7x to the 4th power times 5x minus 2x to the 4th power times 5x. 7 minus 2 is 5x to the, and here's our answer. I have one more here that we could do. Number 9, here's number 10. We're adding and subtracting. So we have cubic root of 54 n to the 5th power minus the cubic root of 16 times n to the 5th power. Okay, so let's see. 54, we need in this case cubic roots, all right? So we need half of 54 is what? Is 27. Divided by 3 is 9, and 9 divided by 3 is 3. So here we go. We have 2 and 3 to the 3rd power. 3 times 3 is 9. 9 times 3, 27. So we have 27 times 2 is 54. And with 16, what do we have with 16? 8 times 2, right? So let's do it. So we have 27 square root times what? We're going to divide this one too, right? This is going to be n to the 3rd power, and what do we have left? N to the 2nd power. So this is going to be n to the 3rd times n to the 2nd. I'll show you another way, easy way to do it. We could do it this way, or this is third. right here, x to the third and n to the second. So we could write down the ones that have the perfect cubic root, which is going to be the 8 and the 9 to the third power. And the ones that don't have it is the 2 and the n squared. We could do it like that. Okay? So we said this is 3. From here we get 3. From here we get n. So we have 2n squared minus, what do we get here? 2n, and we just have this one here. So this is this one. Okay, and in order to get this one, I use this one and this one. Got me the 3n. Whatever was left goes in here. Now, 3n minus 2n is what? It's going to be just 1n. Cubic root of 2n squared. That's going to be my answer. And we're going to start multiplying radical expressions, okay? So to multiply radical expressions, simple distribute. That's all we have to do here, okay? To multiply radicals, distribute, okay? Now, here's the first example that we have. We have a square root of 2 times 8 minus square root of x. So how do we do this? All right, we have to distribute, right? That's what we just said. So let me do it. So this is going to be square root of 2 times the square root of 8 minus square root of 2 times square root of x. All right, now let's multiply. We have 16 and we have 2x. Square root of 16 is 4 minus square root of 2x. And that's our answer. All right. Now, remember to simplify it whenever you can. So let's try this one too. This is square root of 3 times square root of 27 minus the square root of 3. Just gonna multiply it. We're gonna distribute square root of 3 times the square root of 27 minus square root of 3 times square root of 3. 27 times 3 is 81, and 3 times 3 is 9. What's the square root of 81 is 9. The square root of 9 is 3. And what do we get? 6. Now, let's do this one. Square root of 2 times 2 is square root of 3 minus square root of 6x. So what do we do? Distribute. So this is equal to square root of 2 times 3 is 6 minus 6x, right? 6 times 2, sorry, minus 12. So now 12 is equal to 4 times 3. So we could do square root of 4 times square root of 3x. Square root of 4 is 2 and 3x. And we can't do anything else here, guys. That's going to stay the way it is. Let's do this one. Square root of 6 times square root of 2 plus square root of 18. Okay, so what are we doing there? Trivial. Okay, 6 times 2 is 12. 6 times 18 is 108. So we know that this is what? 4 times 3. And 108 is, we could do it just to find out. Hold on. We can do it on this piece of paper. 108. So divided by 2 will be 54. Divided by 2, we said was 27. Divided by 3, we said was 9. Divided by 3 will be 3. So what do we have? 2 to the second power and 3 to the third power. So we have one square here and another one here. We have 2. 2 times 2 is 4. 4 times 3, 12. 12 times 3, 36. So we could say that this is equal to 36 times 3. You guys saw that there. I multiplied all of these ones times 3. Now, so let's continue. So we have square root of 4 times square root of 3. Square root of 36 times square root of 3. Square root of 4 is 2. Square root of 36 is 6. Same radical. 6, I'm going to add the coefficient, so it's going to be 8 square root of 3. That would be my answer. Now let's do one couple more that I have here. This one. Four, 5. So we okay. So we know this is equal to what? The square root of x minus 5 times the square root of x minus 5. Correct? So let's multiply it. This is going to be square root of x squared. This is going to be minus square root of the 5 is going to go outside and the x could be inside. Negative 5 square root of x plus 25. I can combine those two like terms, and what do we have? 10. So what we have is a square root of x squared plus minus 10 square root of x plus 25. And that's an answer. Now, and I have one more multiplication here. This one is square root of 5 minus 5 times 2 square root of 5 plus 2. Okay. So then this one multiplied. So it's going to be 2 square root of 25 plus 2 square root of 5. This is going to be minus 10 square root of 5 and negative 10. Right? Now, those are the only two that I can combine. Nothing else. Oh, square root of 25 is 5. 2 minus 5, negative 8, right? Square root of 5 minus 10. So this is 2 times 5 is 10. I keep writing. So we're making a 1 here, and what do we have left? Negative 8 square root of 5. That's the only thing. We can't do anything else. Now, recall when we did a plus b and a minus b, right? And that's equal to a squared minus b squared. You guys remember this rule, right? And what is the name of this rule? It's called the difference of squares. It's called the difference of the squares, all right? And what do we call, I have a question here. What do we call a plus b and a minus b? I believe I said it before. They are the multiplication of conjugates, okay? The multiplication of conjugates, all right? So now, so what happened when we multiplied these conjugates? Let's see what happens. So hold on. So we will do a square root of a minus a square root of b times a square root of a plus a square root of b. And we're going to multiply them and see what happens, all right? So the first one, that will be a squared. Then that will be plus ab minus what happens right in the middle we make a 0, right? So what do we have left? We have left a squared minus square root of a squared minus square root of b squared. So this is going to be equal to what? To a minus b. Now, what are the conjugates? Here's the statement. What are the conjugates of, and I'm just going to give you this one, x plus the square root of 2. What would be the conjugate? Okay, the conjugate is going to be x minus the square root of 2. All right? And this is a. What would be the conjugate? The conjugate is going to be plus exactly the same, but opposite signs. That's what the conjugates are. Now, let's multiply them. Let's do that. So we're going to multiply so we're going to multiply conjugates, and we have square root of y plus 4 times square root of y minus 4. Right? So what do we get there? All right, let's do the multiplication. The square root of y times square root of y. What do we get? Y square root of y squared. We get negative 4 square root of y. Right here we get positive 4 square root of y. And right here we get negative 16. And what do we see here? Make a 0. So we make a 0, and what do we have left? We have a y and a 4. I mean, not a 4. I thought that was the square root, sorry. Negative 16 minus 16. That would be our answer. Y minus 16. Let's do a few more of the conjugates, okay? So we have we're going to multiply. So we have square root of 3 minus square root of 5, square root of 3 plus square root of 5. Again, if we do it, 9, then this is going to be negative 15, and this is going to be negative 25. Right here, what do we say? Make a 0. Square root of 9 is what? 3. Square root of 25 is 5. So my answer is going to be negative 2. Now, so just notice that the square root disappear when we do the multiplication. When we multiply by conjugates, notice that the square root disappear when we multiply by conjugates. So notice that the square roots all of them. When we multiplied by the conjugate, okay? And I need to so notice that the square roots disappear. You see what we have? Look at this one that we just did, negative 2. And let's do a couple more. We have 3 times the square root of 5 plus 2. We're going to multiply it by the 3 times the square root of 5 minus 2. Okay? So we're going to distribute again. And we're going to see how the square root appears. So we're going to, 3 times 3 is 9, a square root of 25. This is negative 6, square root of 5. Positive 6 is square root of 5. I'm multiplying these two. And negative 4. Again, we make a 0. And what do we have? We have a 9 square root of 25 minus 4. 9 times 5 minus 4. This is what? Equal to 45 minus 4, which is 41. So we make a 0. And then we do the square root of 25. Look at this one. This is 2 times the square root of x minus the square root of y. We're going to multiply by the conjugate plus square root of y. So this is 4 square root of x squared. 2xy. Y squared. So again, right here, make a 0, and I have a 4 times x minus y. So my answer is going to be 4x minus y. So now we use the pattern that they have there. What number was this one? 4, 5. If we multiply using the product of conjugates pattern, which is a minus b times a plus b, is a squared minus b squared. So we're going to multiply using the product of conjugate pattern, okay? And this is what we're going to be multiplying. 5 minus 2 times the square root of 3, 5 plus 2 square root of 3. All right. There we go. The answer needs to be a squared minus b squared. we know this is a minus b, a plus b, right? And we need a squared minus b squared. So my a squared is going to be 5 squared. Right? So this is going to be 2 times 3. Hold on. No. This is going to be 2 square root, sorry. Just erase that from your memory, okay? Your mind. That's how it's going to be. So I have 25 here, but what do I have here? Okay. This is 2 square root of 3 times 2 square root of 3. So I have a 4 square root of 9, which is 4 times 3, which is 12. So it's 25 minus 12, which is 13. That's using the product of conjugates pattern, okay?